welcome back to my channel. So today we are going to discuss lead code problem number 1611, that is minimum one byte operator to make integer 0. So in this problem, let's see how it is. It is the hard level problem, and at first it looks pretty tricky because of the bit manipulation and the operation rules, but once we break it down properly it becomes super logical. So let's understand it step by step. So the problem says that we are given an integer n after that, and we need to transfer it into the O, which is we need to transfer it using some certain kind of operations. So there are two allowed operation. That is, first we can flip the rightmost bit, that is the 0th bit of n, or we can flip the ith bit and like of the n, like represent of n, and if the bit before it, and that is the I minus 1 nth bit is 1, and all bits to the right of that are 0. So we need to figure out the maximum numbers of operations to be performed or required to make n into 0. So we are given two examples. Let's see this first example. We are given input n equals to 3. The binary representation is 11, as it is given here. And according to the rules, we can flip the second, first we can first flip the second bit, and because the oth bit is already 1, so the 11th becomes 0 1, then we can flip the 0th bit to get the 0 0 0 0. So that's two operation in total. Similarly, if we have n equals to 6, so we will be doing like, which is the binary is 1 1 0, so it takes four operation to make it 0 0 0. So now let's get a glimpse on like the problem that would require recursion or a lot of manual bit flipping logic. But here's the trick: this entire problem can be solved using the concept of the gray code. So what's happening here is that the number of operations need to turn into n into 0 follows the pattern of inverse gray code transformation. Gray code is a special binary sequence where two consecutive numbers differ by exactly one bit. So in this problem, the number of bit operations to reach 0 is basically the inverse gray code value of n. To compute that inverse gray code, we can use a simple bit manipulation trick. We keep XORing n with its right shifted version until n becomes 0, and that's exactly what the code does. So let us go through the code line by line. As usual, I believe in writing it first, and honestly, the code doesn't seems to be that big. So here I have written int result equals to 0. After that, we will use a while, and is greater than 0. Result is equals to n, and n is greater than equals to 1. So till here it's done. Then we will return the result. So this is just this much of the code, to be very honest. And here how it starts. So we will start with a variable result initialized with 0. Then in each iteration we are XORing result with the current value of the n, and after that we right shift n by 1 bit. Okay, which means we are progressively combining all the shifted version of n using XOR. This continues until n becomes 0, and the final value of result is the number of operation required. So for example, if there are n equals to 6, okay, which is 110, the XOR process internally calculates the inverse gray code transformation of 6, and the final result we get is 4, which is indeed the minimum number of operations to make 6 become 0. This approach is super elegant because it doesn't rely on complex recursion or simulation of bit change. It's just a mathematical way of reversing the gray code sequentially to get the operation count. So, to summarize, the problem is about flipping beat with specific rule. The trick is realizing its equivalent to finding the inverse gray code of n, and the efficient solution is to keep XORing n with its right shifted version until it becomes 0. So, let us run this code and see if our cases are running. So, yes, our cases are running, and then we will be submitting this whole code. So, it will also get submitted. Yes, it's accepted definitely. So, that's how we will solve this hard level problem in just a few line of code using bit manipulation. If you found this explanation helpful, do not forget to like the video, subscribe, and share it with your friends who are preparing for interview or competitive programming. Thank you.